All right, so in this section, we're going to take a quick look at one major type of reactions known as oxidation reduction reactions. And oxidation reduction reactions are often referred to as redox reactions, which comes from combining the read part of reduction and the ox part of oxidation. And we can define oxidation reduction reactions as when electrons are transferred from one thing to another. And the key thing you want to keep in mind here in your redox or oxidation reduction reactions is that if electrons are being transferred, one thing, one substance, has to be losing or giving up the electrons, but those electrons don't just disappear, they have to go somewhere else. And whichever thing accepts those electrons, we say that that one's gaining those electrons, it's going to be reduced, right? So if something is losing electrons, something else has to gain them, right? Because the electrons don't just disappear. So we can define oxidation reduction reactions in terms of electrons. So redox reactions in terms of electrons. And we can say that things can be oxidized or reduced depending on whether they're losing or gaining electrons. So we can say the loss of electrons is oxidation. Okay, so if something is losing electrons, we're saying that it is being oxidized. And alternatively, we can say that the gain of electrons is just the opposite, which would be reduction. Okay, and again, what you want to keep in mind is that reduction and oxidation must happen simultaneously. So they must happen together. So if something is undergoing oxidation, something else has to undergo reduction. And we can make a little mnemonic to help us remember this. All right, we can say loss of electrons is oxidation. So we have LEO. And then gain of electrons is reduction. And GER kind of sounds like GER. So we can say Leo, the lion, goes GER. GER, if you want to be a little more fierce. So that's in terms of your electrons. All right, so we can define reduction and oxidation in terms of electrons. If something is becoming oxidized, it is going to lose electrons, as substance A in this case. And if something is oxidized, something else has to become reduced, and that's the thing that is going to be gaining your electrons. All right, so I just mentioned, a mnemonic Leo goes GER. Another more common mnemonic is this one called oil rig, which stands for oxidation is the loss of electrons, and then reduction is the gain of electrons. And that is specific to electrons. So how does that affect what you actually see in a reaction? Well, when electrons are lost, you end up taking away a negative charge, so you're going to end up with something with an overall positive charge. Whereas if something is gaining electrons, you're adding negative charges to it, so they're going to form negative ions. All right, and we can actually look at the charges on our substances to determine whether electrons are gained or lost. Okay, and one thing to keep in mind when we start looking at our charges, remember that elements, have no charge, they're neutral. All right, so we can take a look at a chemical reaction and we can assign the charges and we can see whether or not something is undergoing oxidation or reduction. And the way that we can view this is if the charge becomes more positive, right? That means you're losing electrons. This would be oxidation. And then the opposite would be true. If the charge becomes more negative, then that would be reduction. Okay, so an example of where this can happen would be copper, for example. And as you probably know, copper has a very brownish red color. Well, the Statue of Liberty is actually made out of copper, but it's not red-brown. It's actually green, sort of like a light greenish bluish color. And that's actually due to the formation of or the reaction between copper and oxygen. And as a result of that reaction, we see that the copper becomes oxidized and the oxygen becomes reduced. So let's take a look at that particular reaction, because oxidation reduction reactions actually are really, really, really common. So we need to know how to interpret them. So if we have copper, which is a metal, so it's just a solid, reacting with oxygen in the air, O2, which is a gas. Okay, this can form copper oxide, copper 2 oxide to be more specific. So CuO. And that's a solid. So let's go through and let's identify the charges on these things. So copper here, okay, that's the metal. It's in its elemental form. So the charge here is 0. Right? Any element is going to have a charge of 0. Similarly, oxygen occurs naturally as a diatomic molecular element, so its charge is also going to be 0. Now they combine to form our ionic compound CuO, and now we can use what we learned in the previous chapters about ionic compounds, right? Ionic compounds, this is an ionic compound because there's a metal and a non-metal, and ionic compounds are made up of ions. So oxygen normally forms, because it's in group 6, would normally form a -2 charge. And because this entire compound has to be neutral, it means the copper then has to have a +2 charge. Okay, and just to make sure that this equation is balanced, I'm going to balance it. So you have 2 copper oxides, and then we're going to have 2 of the coppers here. The coefficients that we use to balance, those don't affect charges. Those just make sure that we don't lose or gain atoms. So we've identified the charges on everything in this reaction, right? The copper starts off as copper metal with a charge of 0. Oxygen starts off as elemental oxygen, charge of 0. Now what happens to the copper? Well, it goes from a charge of 0 to +2. All right, so the charge there increases. 0 to +2, it becomes more positive. So then we can say that would be oxidation. Okay, and once you figure that out, well then by default, the other thing in this reaction, which is the oxygen, has to be reduced. And we can confirm that because the charge goes from 0 to -2. So the charge decreases. It goes from 0 to -2. So we say the oxygen then is becoming reduced. It's undergoing reduction. All right, so we can look at a reaction. We can identify the charges on the reactants and the products and see how they change, whether they're increasing or decreasing. And we can then assign whether that thing is undergoing oxidation or whether it's undergoing reduction. We can also identify oxidation and reduction reactions in terms of something a little more obvious. So reduction oxidation can also involve the loss or the gain. So we just looked at electrons. Well, reduction and oxidation can also involve the loss or gain of oxygens or hydrogens, right? And this is going to be particularly applicable to biological systems, like what's happening in your body, for example. And it's going to be a little bit more obvious. So we can also define reduction and oxidation the same way like we did with the electrons. All right, so we'll just sort of, let's do a little table. So we'll do oxidation first. And we have reduction. Okay, and we just saw in terms of the electrons, oxidation is the loss of electrons, which means the reduction then would be the gain of electrons. And this then is manifested in the charge, all right? In an oxidation, the charge on that species increases, becomes more positive, which means for reduction then the charge would decrease, become more negative. Okay, so that's the first thing we can look at. We just looked at our reactions. What we just said now is we can look at oxidation and reduction in terms of hydrogens and oxygens. So oxidation is also can be defined as the loss of hydrogens, which means reduction would be the opposite of that, which would be the gain of hydrogen. And then thirdly, we can look at oxidation and reduction in terms of oxygen. And maybe it might have been maybe obvious to you when we first introduced oxidation. Oxidation just kind of sounds like adding oxygen. And that's exactly how we can define it. Oxidation can also be defined as the gain of oxygen, which means reduction, which is always the opposite, then would be the loss of oxygen. All right, so we can look at oxidation reduction in terms of three different perspectives. We've already looked at the first part here, the electrons. Let's take a look at the second part, the loss or gain of hydrogens. So for example, in biological systems, let's say that your body is trying to break down a biological molecule, let's say something like a sugar, for example. Right, we have these things called coenzymes in your body that are able to help do that. And this coenzyme here, called FAD, is able to gain a couple hydrogens from that biological molecule. All right, so our sugar, for example, now ends up losing those two H's. So it undergoes oxidation. And those two H's end up being transferred to our coenzyme thing, FAD, and that gains two H's and it becomes FADH2, right? So if we stick a couple extra hydrogens onto it, it's gaining hydrogen. That would be reduction. So in terms of the loss or gain of hydrogens and oxygens, it's a little bit more obvious in terms of what's happening. I'll give you another quick example where we can actually do all of those to identify oxidation and reduction. If we have a fuel, something like methane, which is CH4, this, you find this in your gas stoves and your anything that has like a gas fuel. Even the Bunsen burners in lab use this. This can react with oxygen to make CO2, carbon dioxide, and we get water vapor as well. All right, so let's just quickly balance our reaction. And it looks like our equation is balanced. So if we look really quickly here at what's happening to our carbon, let's say. All right, so if you look at the carbon over here, it's got some H's attached to it. Now, what happens to the carbon when we subject it to this process? Well, now the carbon doesn't have any H's attached to it, so the carbon loses H, but it also gains oxygen. So the combination of these two things, the fact that it's gaining oxygen and losing hydrogen, would mean that the carbon is undergoing oxidation. All right, you can also see the hydrogen itself, right, goes from being with carbon, and on the right side it ends up being attached to oxygen. Now, if you look at the oxygen itself, okay, this O here is by itself to begin with, and at the end, if you look at here, for example, right, we end up attaching it to hydrogen. All right, so the oxygen then gains H, so we can say then the oxygen undergoes reduction. So in some instances, it's a lot more straightforward to look at the hydrogens and the oxygens to see whether something is undergoing oxidation or reduction. In other cases, you may not have hydrogens and oxygens to look at. So in that case, you look at the charges, which give you an indication of the electrons.